So today we're going to look at another way to calculate concentration or to think about concentration, and this one's simple, it'll be more familiar to you. It is percent by mass, and you've probably done percentages in math class since maybe elementary school. And so this is no different. It's the part divided by the whole times 100. In this case, the part we're usually looking for is the solute, the mass of that solute. It could be the solvent, you would be told, if it wanted to know the mass percent of the solvent instead of the solute. But if it doesn't say, assume that it's the solute, divided by the total mass of the solution. So this would be the mass of the solute plus the mass of the solvent together. And so you'll find that ratio, multiply by 100 to make that into a percentage. And it's not always that easy. This is a really easy calculation, but it may be that you have to do a little work to figure out the mass of the solute or the mass of the solution, or sometimes they might ask you for some other piece of information based on the percent. So we're going to look at some problems that, that you might run across with these kinds of calculations. And we're also going to look at how you can go back and forth between different units of concentration. So if I know the percent by mass, I can figure out the molarity and vice versa. So we'll take a look at some problems like that. And as always, you'll have a chance to practice those a little bit before we assess you on a test or a quiz. All right, so here's our first problem. This one's a little simple and straightforward. So it says calculate the mass percent of a solution formed from 27.3 grams of lithium sulfate, which is Li2SO4, dissolved in 150 milliliters of water. And water's density is 1 gram per milliliter. So why do they tell me that? Because I need a mass. And they didn't give me a mass. They gave me a volume in milliliters. But water is easy. Since it's 1 gram for every milliliter, that means if it's 150 milliliters, it's also 150 grams. And I know that because of the density. Water is the only substance that you can just make that assumption. Otherwise, you would have to do a calculation. So this problem is not bad at all. I need the mass of the solute, which is given to me straight out there, 27.3 grams of lithium sulfate. Don't need the formula here, don't have to go to the periodic table, which is a nice change of pace. And that's going to be divided by the total mass of the solution. So I've got 27.3 grams of solute plus 150 grams of the solvent. So my total mass there is 177.3 grams. If you missed that, that's 150 plus 27.3. That's how I got the 177.3 grams. This is my total. All right, so since it's a percentage, I'm going to multiply by 100, and then it's just a matter of doing the calculation. So 27.3 divided by 177.3 times 100, and you can probably do that in your head, just moving the decimal 2 places to the right for that part. So 15.397, I've really got just 3 sig figs here, and so we're going to call that 15.4. And this is a percent. No problem. That one's pretty simple. Let's add just one little layer to this one. So this is calculate the mass percent of a solution formed when 15 grams of polystyrene, and that's actually styrofoam, dissolves in 200 milliliters of acetone, which you might be familiar with as fingernail polish remover. That's a main component of the ones that are not non-acetone. The density of acetone is not 1 like water's. It's 0.784 grams per milliliter. And so given this volume, I'm going to have to figure out the mass given the density there. So for mass percent, I need the mass of the solute, which I have. I'm dissolving polystyrene. So that's 15.0 grams of solute. I need the total mass of the solution. So here I'm going to have to do a little work before I can put something in my problem and multiply by 100 to get my answer. So I'm going to come down here below and work this out. So I've got 200 milliliters of acetone and it is 0.784 grams for every milliliter. I don't know if you remember this from Chemistry 1. I'm not sure if we did this in Chemistry 1. We used to. But since standards have changed, we may not have done this. You can use the density as a conversion factor. What this means is 0.784 grams is equal to 1 milliliter. So if I want to cancel out milliliters, the milliliters will go on the bottom, and the mass there will go on the top. You could also solve this using the density equation, which is D equals M over V. Sorry, couldn't see that. But you can do it this way too. Pretty simple. So 200 times 0.784 is 156.8 to 3 sig figs. That will be 157 grams. So that's my solvent plus the 15 grams of solute gives me what, 172 grams of solution. So that's what goes on the bottom of that calculation. And then just a matter of doing the math. 15 divided by 172 times 100, 8.72%. Again, a little more complicated. There is one more step there, but still not bad at all. You guys shouldn't have too much trouble with this. Now, a little different question. What is the percent by mass concentration of a 0.175 molar solution of calcium nitrate? And it says, assume the density of the solution is 1 gram per milliliter. Well, why do I need to know that? I don't have a volume here, but we'll get to that. So this is a little tricky if you've not seen this or tried to think through it before. So let's think about what we know from this this problem. We've got 0.175 molar, and so what is that? 0.175 molar is 0.175 moles of calcium nitrate in 1 liter, and that's exactly 1 liter. I'm going to give it 3 sig figs because that has 3 sig figs. I could give it 20 if I wanted to, but 1 liter of that solution. So I'm going to assume here, and you can assume anything you want to for this volume, but just to make my life a little easier, I'm going to assume I'm working with 1 liter of solution. And if I'm working with 1 liter of solution, I know I've got 0.175 moles of calcium nitrate. If you want to assume half of a liter of solution, then assume half that number of moles of calcium nitrate. If you want to assume you've got 2 liters of solution, then double your amount of calcium nitrate. But why bother? Let's just use this. So I know a couple of things if I make that assumption. One of them is how much calcium nitrate I have. And since I need, of course, the mass of solute, I can convert that to a mass. No problem. So let's do that first. 0.175 moles of calcium nitrate. And 1 mole is how many grams? So using my periodic table, I'm going to find calcium at 40.08 plus 2 nitrogens. So each one is 14.01. Sorry, you can't see that. 14.01. So 2 of them would be 28.02. Plus 2 times 3 gives me 6 oxygens. Oxygen is 15.999 or 16.00. So 16 times 6 is 96. So my molar mass is 164.10 grams for each mole. So moles cancel out. So in that liter of solution, I'm going to multiply this times this. I actually have, there we go, 28.7175, 3 sig figs, so 28.7 grams of calcium nitrate. So there is my mass of solute. I've got the top part of the fraction that I need. Now I need to find the total mass of solution. That's where your density comes in. So here, since we're using this, we're assuming we've got 1 liter of solution. And so remember from your chemistry 1 liter is equal to 1,000 milliliters. And again, that's exact. So don't worry about sig figs there. So if this is 1,000 milliliters with the density of 1 gram per milliliter, this is also 1,000 grams, and this is of solution. So this is the density of the solution, not just of the solvent. And you'll find that very often with solutions. To the number of sig figs that we use, the density, if it's fairly dilute, is still going to be pretty close to 1, and so we just make that assumption, and it's a pretty valid and safe assumption. So now I have what I need. I know the mass of the solute, I know the total mass of the solution, I can calculate percent composition, or percent by mass. 28.7 grams solute divided by 1,000 grams of solution times 100. And so, moving my decimals around here, I'm gonna do that. So it's gonna be 2.87% by mass. Alrighty? Not too bad. All right, I've got a couple more problems. I think I'm gonna need to do that in a separate video, so we'll stop this one here, and I'll do a couple more examples in the next video. You're probably okay to start on your practice problems, but if you get stuck, definitely come back and watch this next video, because that'll get you unstuck. I'm gonna show you pretty specifically some of the skills that you're going to need as you move forward into the practice problems and the little quiz that follows. So I will talk to you soon.